Now we would be looking at the steps for setting up Spark in your system. I am going to be using Windows operating system as my reference, particularly Windows 10 because that's my system. So there are two steps involved for getting you set up with Spark. The first one is downloading the latest version and all of its dependencies, and second is to set up the environment variables. We will first start with downloading the latest version. So to download Spark, you can go to spark.apache.org and go to the downloads page and download the latest version from there. Second, we will be needing a executable file called WinUtils, which can be found at this GitHub link over here. Besides these two things, we will also be needing a program to handle compressed files. It could be 7-zip, WinZip, or any other freeware of your choice. In your C drive, create a directory for Spark. I'm using this given directory over here, which is C big data local setup Spark, and paste the files from the first link, that is the spark apache.org download link, and extract the files and paste them in a folder called Spark. The second downloadable file, that's the winutils.exe, we will be placing them in a separate directory which is located over here. Now over here you can see the download pages for both of these files. So this is what the Spark download page looks like, and this is the GitHub page. Here's the download button where you can download the executable file. The second step is setting up the environment variable. So for that we would begin with clicking on Start, edit system environment variables and new. Over there we will be adding two new values. For the first value, it's going to be variable name is going to be Spark, and the value is going to be the path for where we had extracted the files. The second variable name is going to be Hadoop_home, and the value is going to be the path where we pasted the .exe file, which was right here. After that, we click on OK and then click on the path variable which already exists over there, and enter these details by clicking on new. That's %spark_home %/bin and %hadoop_home %/bin. After that, you click on OK and start command prompt and start Spark. If everything is done properly, it should start. Here are a couple of screenshots just for your reference and about how to set up the environment variables. So this was step 1 in the start menu. After start menu, we go into edit the system environment variables. We go into edit variables, we create a new variable over there. We create Spark home with the variable value being the path of the folder where we extracted the files. The second variable name being Hadoop_home, where we pasted the .exe file. After that, when we click on path, which is over here, this is going to be our new. Over here we will be creating the new values, that's %spark_home/bin, and same for Hadoop. If done correctly, all of this would lead to
Talking about getting started with Spark. So it's a free and open source replacement for Hadoop's MapReduce. It's basically a tool that manages the transformation of data. It's a parallel data processing framework that works with Apache Hadoop to make developing sophisticated big data applications on Hadoop easier and faster. It includes a large number of libraries for machine learning and graph algorithms. It can be developed in any language such as Java, Scala, or Python, and they run almost 10 times faster on disk and 100 times faster than MapReduce applications. So now I'll be discussing about the features of Spark. So in Hadoop clusters, Spark apps can run up to 100 times faster in memory and 10 times quicker on storage. So hence they are have a fast processing speed. Also, Spark applications can be written in any language: Java, Scala, Python, and R. This gives the developers scope to create Spark applications in their preferred languages, so hence they are easy to use. Also, they can read existing Hadoop data and also run independently on Hadoop Yarn Cluster Manager, and thus is flexible. The Spark code can be reused for batch processing, joining streams against historical data, and doing ad hoc queries on stream state. Because Hadoop requires a huge amount of storage and a large data center for replication, Apache Spark is a cost effective solution for big data problems. Spark also supports SQL queries, streaming data, and advanced analytics, ML and graph algorithms in addition to supporting map and reduce operations, hence, it supports sophisticated analysis. It also provides ATL high level operators with the help of which a parallel application can be easily developed, hence, they are dynamic in nature. It also ensures that the loss of data reduces to zero with the help of Spark RDDs. So, RDDs record data on multiple nodes and hence they reduce the occurrence of faults. So now we'll be talking about the anatomy of Spark. Any Spark application comprises of two core components. One is the driver process and the other is the executor processes. So the driver process is in charge of calling the main function. It also takes care of three things: keeping track of the Spark application, responding to user code or input, and analyzing, distributing, and schedule working across the executors. The driver process is the heart of the Spark application. It stores and maintains all vital data during the application lifespan. The executor process are secondary processes. They must complete the duty that the driver has assigned to them. Each executor has two purposes. It executes the code that the driver has assigned to it, and it reports the state of the computation on that executor to the node to the driver node. The number of executors that each node should have is up to the user to select. So the question I would ask is, which feature of Spark puts RDD to use? And the answer is fault tolerance Spark.
Shita Gupta. I'm talking about simple Spark applications. Applications. A Spark application is a self-contained calculation that computes a result using a user-supplied code. An application is Spark's highest level compute unit. Spark, as a cluster of computing framework, schedules, optimizes, distributes, and monitors applications made up of numerous computational jobs across a computing cluster, many worker machines. A Spark application can be used for a single batch job, a multi-job interactive session, or a long-running server that responds to requests simultaneously. Spark applications can be written in any of the three languages that are supported: Scala, Python, Java. The driver, executor, task, job, and stage concepts are all used in the Spark application. This is the architecture. Here we have driver program and then cluster manager along with two worker nodes in which we have executor, cache, and two tasks. Simple Spark applications continued. We have accumulator, parallelize, broadcast, for each, which is also called as reducer. So accumulator stores variables that can be subjected to additive and cumulative functions. It is safer to use a global declaration. Parallelize, it saves iterable data such as list to a distributed dataset that may be delivered to network clusters. Broadcast sends a variable to the rest of the cluster's memory devices. Pre-built efficient algorithm that aids in the reduction of communication expenses, can only be used if all nodes require the same data. For each, it is also called as reducer, runs a function on each element in the dataset. For safe updates, the output should be an accumulator object. This is the word count Spark application. This is the code of it. Thank you.
Hello everyone, today I'll be explaining a program how to compute averages of an array using program to compute sum of an array. Here the cluster name is defined.
Hey everyone, my name is Anusha and I'm going to talk about Introduction to Scala. So Scala is an object-oriented programming language which can be executed on Java virtual machines once it's converted to bytecode. And there's no such thing as primitive data types at all. Everything is an object in Scala. Next, I'm going to talk about why you should use Scala. So these are some of the obvious reasons, like it's easy to use and it contains some of the best features, and it has close integration with Java, and it can be used for web-based and desktop application development, and it's used by some of the big companies. And these are the advantages of using Scala. So it's mostly used in data analysis with Spark, and it's used to develop web applications and API, and it provides the facility to develop the frameworks and libraries, and it's used for parallel batch processing. And finally, these are the disadvantages of Scala. It has no true tail recursive optimization as it runs on Java Virtual Machine, and it always revolves around object-oriented programming, which can be a disadvantage as every function is value and every value is an object in Scala. And sometimes two approaches make Scala hard to understand. So that's the end of the introduction to Scala. Thank you.